A pleasant day, everyone. Welcome to our lecture for today. So, our topic for today is about the introduction to rate of change. Before we go to the rate of change using the differential calculus, let us review what is rate of change, what we had discussed in our analytic geometry. Okay, so for today, before we begin, let us start with the objective of this session for today. So our objectives for today's session. So the first one is understand the basic concept of rate of change. So at the end of this lecture class, you should be able to understand the basic concept of rate of change. And then the second one is understand what a rate of change means in context. And the third one is how to calculate rate of change given the graph of a linear relation. Okay, so let's have a quick example here of what is rate of change. So our example here is about earnings versus time worked. So we have here our actors. We have Mario and Luigi. So if you can still remember, no, there was a game about these guys. So they are plumbers. So they are earning. The earnings are shown in this graph. So if you look at Mario's earning, so look at the vertical. This is the earning in terms of dollars, and then this horizontal part is. This is the time work in terms of hours. So if you look at Mario's earning, we can see here that half of an hour, so he earned already $10. Or if we look at here the first hour of Mario's work, he earns $20, right? And as you move to the second hour, so Mario already earned this much for 2 hours. He earned already $40. Or for 3 hours, he earns 60. For 4 hours, he earns $80. All right. Now, if you look at Luigi, so his first hour was only $10, right? So 1 hour, first hour, that's equivalent to $10. And for the 2 hours, so Luigi earns only $20. And as you go on to the 3 hours, he earns 30. And if he work 4 hours, he earns $40. If you work 5 hours, he earns $50. If he work 6 hours, he earns $60. So if you look at Mario's earning, once again, for the first hour, he earns 20, right? For the second hour, he earns 40. The third hour, he earns 60. And the fourth hour, he earns 80. So this is 80 here. So we can say that this is Mario, and this is Luigi. Okay, so we can see using these red graphs here, or red lines. So we have Mario earns $20 per hour, whereas Luigi earns $10. Luigi earns $10 per hour. Okay, so we can see that these are the hourly rate of Mario and Luigi. Okay, so I hope you have understood the concept of this rate of change. So as you have seen a while ago, so we have, as we move the hours, there's a corresponding change of the earning in dollars. So that is rate of change. In this graph, we can easily see what is the corresponding earnings every hour. Okay, but there are times that it's not easy. No, it's not easy to find the corresponding rate of change for a given graph. So let's take a look at another example. So we have here calculating rate of change from a graph. So this is our graph here. If you look at this blue line, okay, so as you look at 0, it means this is a month on cell phone plan. So this is the cost versus months on cell phone plan. So the vertical here, the vertical or the numbers on the vertical line is the cost of the cell phone plan, and this horizontal line here we have 1 2 3 4 5 6 7. These are the months on cell phone plan. So as you see here in the beginning, even if before you use the phone, there's already a corresponding amount that is 100. So perhaps this $100 here is the cost of the activation. So even if the service is not started yet, but there's already a corresponding cost. So looking at this graph, we can say that if you look at here, on the first month, there's a corresponding $50 because we have 100 here, 200, so half of it. So this is 50. Okay. So as you move to the second month, so that's 200. And if you move further to the third month, you see 250. Right? So there's an increment of, so there's another 50 here. So this becomes 250. On the fourth month, so that's 300. On the fifth month, so you have 350. Right? This is 350. And on the sixth month, so this is 400. So we see that there's a change every month of $50. So there's a change of $50, $50 per month. All right. Now there are times, class, that it's not easy to get the rate of change from the graph. So in that case, we are going to use the concept on the rise over run. If you can still remember, in our analytic geometry, we have this concept. We have rise. So this is in the case that you cannot read the graph properly. So you can use this rise over run. Okay, so we'll use this idea here to find the rate of change of the cost versus month on cell phone plan. So the concept here is to choose or to select 2 points, any points on the graph. Just choose the points where you can easily read the corresponding value. For example, at this point here. So at this point. Okay, so we know that even before the service started, so at 0 month before the service started, so there's also already a corresponding charge of $100. Okay, and then let's pick up another point. Say for example, at this point here. We can choose any of these points. Say for example at the 5th month. Okay, so let's at the 5th month, let's select this point here. So at the 5th month, this is the corresponding cost, that is $350. Now what I'm going to do is to draw a line from this point. I would like to connect these 2 points, class. This point here and this point. So connecting these 2 points, first I have to draw a line going up. Okay, so this is my rise. Now this is my rise. So this graph is my rise. Okay, and then run. So this is the run. So we talk about run because people run, no, from side to side. Okay, so if you look at this graph again, just look at the distance, no, from this point to that point. So you are now at 100, and then you go up to 350. So we can say that the distance, if you look at the distance, so we have from 100 to 200, that is 100, right? Then 100 to 300, that is another 100, so 200. Then now you go up halfway to 400, so another 50. So this is 100 plus 100, then you have additional 50. So all in all, the rise is equal to, this is equal to 250. So this is our rise, 250. Okay, so rise is equal to 250, and this is in dollars. Okay, now the run. So let us look at the run. So the run starting from 0 to 5 months. So 0 to 5 months. So what is our run? So our run is equal to, this is equal to 5. Alright, so our run is equal to 5. So 5, what is the unit? That is in terms of months. Okay, so months, so 5 months. So we have 5 months. Okay, so we divide 250 by 5. So what is 250 divided by 5? So this is equal to $50, no? $50 per month. So this is the rate, no? Rate of the cost per month, rate of change. Okay, so I hope you got the idea of what is this rate of change. So what I'm going to present you next is about the concept on the success criteria. So we have what we call success criteria here. So what does it mean? To calculate the rate of change, so we need this criteria, class. So what are the criterias? First, we need to choose any 2 points along the graph. Alright, so any points along the graph, and determine the vertical. So what does it mean, vertical? That is the rise. Vertical means the rise, and the horizontal, which is the run. Determine the vertical or the rise, and horizontal or the run distance between 2 points. And after that, you calculate the rise over run. Or we have rise divided by run. Okay? And we have to take note that the greater the rate of change, the blank, the line. So what does it mean? So let us go back to Luigi's and Mario's example. So if you look at Luigi's and Mario's earning versus time worked, so we can see here that the graph for Mario, so Mario is earning more than Luigi in terms of per hour. So you can see that the graph is stiffer than the graph of Luigi. So Mario's graph, the earning versus time work of Mario is stiffer than or steeper than Luigi's earnings versus time. So we can see that the greater the rate of change, the greater the rate of change, the steeper the steeper the line. Okay, so I hope you got the concept on this class, and let's have another example. So our next example here is about the problem to determine the rate of change in savings for Mr. Moneybags bank account. So here in this picture, we can say that this is savings versus time in month. So we have here the vertical, or the numbers in the vertical parts. This is the saving in terms of dollars. Okay, and then we have here the horizontal, that is the time in terms of months. Okay, now let's use the success criteria. Now what is mentioned in the success criteria, we have to choose any points. Be sure that when you choose the points, you can read. Like for example, this one, if you choose this point here, so it's hard, no? The month is clear. This is 1 month, 0 2, then this is 1 month. Okay, this is 1 month here. But if you look at this point here, it's not clear how much is that. So better to choose a point where you can read properly or clearly the values. Like for example, if I choose this point, okay, so I can read clearly that this corresponds to $1,200, and this corresponds to 3 months, right? This corresponds to 3 months. And let's find another point where we can read the values clearly. Okay, so let me choose this one, no, because here at this point I can read this is equivalent to 9 months, and the corresponding amount, which is 800. Okay, so now let's we have already done the choosing of 2 points. So next we are going to draw our vertical and horizontal line. So from this point, I will draw line going down and then draw horizontally, to connect this point. So from this point, so I'll draw a line down. So this is my rise. So but now our rise is decreasing, no? It's going down, and this is our run. All right, so our rise here is, so how much is that? You see, 1,200, and then next the half of it is 1,100, and 1,000. So it means this is 200, or every square here corresponds to 100. Okay, so this is 100, another 100, 200, then 300, 400. So this corresponds to 400. Okay, our rise, which is decreasing, is equivalent to 400. But before that, let's write first our formula, that the rate of change, or simply rate, is equal to, from our formula, this is rise over run. Okay, so as you look at the graph, it's going down. We're going down, so it means that our run is 400. This is $400, but this is negative. Okay, negative because it's going down, and divided by, so what is our run? Our run is, so you look at if you look at this is 3, then to 9. So 1 2 3 4 5 6. So from this point to that point, we have our run equal to 6. Okay, so equal to 6. So our rice is negative because it's going down. So therefore, this is divided by 6. So what is this 6? That is in terms of months. So 6 months. So therefore, our rate of change is equal to, so negative divided by positive, so the result is negative. So negative 400 divided by 6, that is 66.67 cents per month. This is per month. Alright, so that is the rate of change. Now, when the line goes up, when the line goes downwards, so what will be the rate? So if you look at the previous example, if you look at this example here, okay, so our rate is positive, right? This is positive. Now, if you look at this, our rate is negative, no? Well, the line is going down, so when a line goes downwards, the rate of change is negative. Okay, so you have to remember this. The rate of change is negative. If the line is going upward, something like this, so we can say that the rate of change is positive. Alright, so in this case, the rate of change is negative. Okay, so next, now to so let us have another example here. I would like you to try this. I would like you to try this. Now just push the video while you're solving it, and then when you are ready, you just play it again. Okay, so this time we are asked to calculate the rate of change in distance with respect to time from the graph. So rate of change in distance with respect to the graph. Alright, so again, we'll use the criteria, the success criteria, to solve for this problem. So we need to choose any 2 points along the graph. Now, which point shall we use, or shall we select? Okay, so here, if you look at this point, the beginning, 300. So I'm sure that in terms of, by the way, the horizontal class, this is the time traveled in terms of hour, h, and this is the distance from home in terms of kilometer. So distance from home versus time traveled. Okay, so selecting this first point, and then now which point, other point that we need to select. So if I select this point, I can read clearly, this corresponds to 10 hours. This is 10 hours, and this also corresponds to 500 kilometers. Okay, 500 kilometers. All right, then after that, I'm going to draw a vertical line. Okay, this vertical line. So this is our rice. So what is our rice, class? So if you look at this number, we have 300 and 400, 500. So we can see that every square here corresponds to 50. So 50 plus 50, 100, plus 50, 150, plus another 50, so 200. So it means that from 300 to 500, we have the rice equal to 200. Okay? And now, let's write first our formula, the rate. So the rate of change is equal to, again, don't forget to write the formula first. So we have rice over run. Okay, so now we have the rice equal to 200, and then connect the points, draw a horizontal line. towards this point. So what is our run? So our run is from 0 to 10. So from 0 to 10, so it means that our run is equal to 10. Okay? Now, substituting, we have our rise is equal to 200. So that is positive because that's going up. And the unit here is in terms of kilometers. So we have to write the unit class because it has a meaning. And then the run, that is equal to 10. So 10 means 10 hours. So time traveled is in terms of hours. So 10 hours. So 200 divided by 10. So that is equal to 20. 20 kilometers. This is 20 kilometers per hour. Okay? So, as I mentioned, we need to write this units because it means something. So, when we speak of kilometer per hour, that means that is a speed. The speed of the time that being traveled from this point to his home. Distance from home. Okay? So I hope you understand this one, class. And let's have another example. So another example here. I want you to try it yourselves. Then just pause the video for a while. Then if you are ready, then just see your result. Okay? Alright, so you're done. So for this problem, we're asked to calculate the rate of change in distance with respect to time from the graph. So this graph is the graph of height above ground versus time. Alright, so we have here the vertical part, the numbers here, that is the height above the ground, okay, in terms of meters, and this is the time in terms of minutes, the time in terms of minutes. So let us calculate the rate of change for this graph. So again, the rate of change, we write it as rate equal to, so from our formula we have rise over run. Okay, so now again, let us choose points. Let us select points, the points where we can read clearly the corresponding values, the horizontal and vertical values of that point. So in this case, I will select this point here. So this point is clearly corresponds to 10 minutes, and the corresponding height above the ground, that is 600 meters. And let's find another point. Okay, so let's select among this, I think this one. If I select this one, this is not clear, no? The corresponding value for the horizontal is okay, but the vertical is not clear. So better to select this one. So from this point, I can easily see that the vertical or the horizontal value of this point is 50. Alright, so from here that is equal to 50. And the horizontal, the vertical, from here to that point, that is vertical, which corresponds to 400. And then at this point, that is from here to there, that is the horizontal distance, that corresponds to 50 minutes. Okay, so now I'm going to draw a line. So where's my rise here? So my rise is, so draw a line going down to up to this point. So this is my rise. So what is the rise? How much is that? So if you look at this, we have 400, 500. So it seems that every square here is equivalent to 50. So we have 50. So 450 plus 50, 500. 550 plus 50, 600. Okay, so our rise here is 200. But since it's going down, Okay, from the point we go down, so this is negative. Alright, and then draw a horizontal line to this point. Then just count how many, because every square here it seems to be equal to 5, no? 5 minutes. So we have 5, 10, 15, 20, 25, 30, 35, 40. So our run here is equal to 40 minutes. Okay, so this is 40 minutes. Now substituting in our formula, so the rate is rise over run, so our rise is equal to minus 200, and then our run is 40 minutes. Okay, so negative divided by positive, so we expect a negative result here. So 200 divided by 40, that is equivalent to negative 5. So the unit here is in terms of meters, right? So 200 meters, our rise is 200 meters. So divided by 40 minutes, so the result is 5 meter or 5 meters per minute. So this is the rate of change. The rate of change of the height per minute, that is negative 5 meters per minute. So negative because if you look at the line, it's going down. Okay, it's going down. So in analytic geometry, we called it as sloping downward to the right. Okay, the other graph, other example, something like this, it's sloping upward to the right. So our result is positive. In this case, in this example, we have a sloping downward. So that is why we have a negative result here. Okay? Now, in conclusion, so this is our conclusion, class. So relations are linear when the resultant graph is a straight line. Then the rate of change of a variable can be calculated by choosing 2 points and using the rise over run concept. And if the lines rises to the right, so what does it mean? Then the rate of change is, what is the rate of change? If the line rises to the right, then the rate of change is positive. Alright? And if the line decreases to the right, then the rate of change is negative. Then the steeper the line, the greater the rate of change. Okay, so the steeper the line, then the greater the rate of change. The greater the rate of change. Okay, so thank you very much. I hope you got something from this lecture class. So it will help us a lot when we discuss the rate of change of a nonlinear graph. And we will use the idea that we have discussed before about the slope. Okay, so that's all for today. Thank you very much, and stay safe and healthy always. God bless everyone. Bye for now.